Did you know that more than 7 million patients in the US and Europe suffer from tricuspid regurgitation? It's not just that. More than 500 new patients are diagnosed with TR every year. However, only 25,000 surgeries, open heart surgeries, actually happen to treat these patients. Surgeries are extremely invasive, they're risky, and ultimately affect the long-term survival of these patients. They also result in significant rehospitalization and overall are a huge burden on our entire healthcare system. Hello, I'm Ramji Iyer, founder and CEO of Laplace Interventional. We're developing a transcatheter tricuspid valve replacement device, a valve that can be delivered in a minimally invasive fashion through a catheter or a tube, therefore minimizing the risk that these patients will associate with significantly down. So why am I the right person to solve this problem? Prior to Laplace Interventional, I was at Caisson Interventional. I was the senior R&D director there. Along with the founders, we built a team of 50 plus people, did clinical feasibility in 30 plus patients, and were successfully acquired by LivaNova in 2017. Along with myself, I have Dr. Rihal from Mayo Clinic as Chief Scientific Advisor and Dr. Yakubov from Ohio Health Riverside as well. Also, Todd Mortier is a strategic advisor to the company. Todd Mortier is a serial entrepreneur and then was also the co-founder of Caisson Interventional as well as Mayako. So I have a really strong team working on the technology. So what's the problem that I'm trying to solve here? So it occurs when the tricuspid valve, which is the valve between the right atrium and the right ventricle in the heart, leaks. Tricuspid annulus is made of very fragile tissue. Also, there are some important anatomical features around the tricuspid annulus, such as the atrioventricular node, structures such as the cords, right coronary artery. So, in a nutshell, it's a very complex native valve with fragile tissue and important complex anatomical features surrounding them. So, you have to pay attention to all of these to develop a robust solution. What are the current solutions that are currently in development? None of them currently exist commercially. So if you look at, there are broadly two categories of solutions. There's transcatheter repair solutions and transcatheter replacement. If you look at repairs, they only reduce TR, they don't eliminate it. And they also interfere with pacemaker leads that may be present and they're procedurally complex. Replacement device, on the other hand, does fully eliminate TR, like the Laplace's device. However, the current ones have significant radial force and are also procedurally complex to deliver. Laplace's solution addresses all of them. What we have done is basically built the valve that you see here that is delivered through the jugular vein in your neck. And we use the catheter to deploy this valve. So we built a lot of prototypes, tested them, done bench testing as well. So in terms of market size, like I mentioned, there are 500,000 new patients being added and diagnosed with TR every year. Even with a conservative estimate, we're talking about a multi-billion-dollar opportunity here. Similar to the transcatheter aortic valve market, similar to the transcatheter mitral valve market, TTVR is also going to be a huge multi-billion-dollar opportunity. In terms of progress, Laplace Interventional was one of the companies that participated in the G-Beta MedTech Accelerator. Since then, we've raised about little short of 150,000 from angel investors as well as the Launch MN grant. We have done significant design iterations, have demonstrated that the design concept works both in bench as well as animal models. We also have a strong IP through 2 provisional patents as well as US utility and PCT applications that have been filed. We have completed the concept phase with the funding that we've raised, currently raising Series A funds, $5 million for the design phase. Conclusion, TR is a huge unmet clinical need. Laplace's solution is truly disruptive in the valve space with significant design de-risking already completed. I do consider myself to be a risk-reduced founder and CEO, given my heart valve as well as structural heart experience. Join me in improving the lives of these patients with TR. Thank you.
Thank you, judges. We have a minute 30.
Could you speak a little bit to your preclinical plans and what the next steps are as far as reducing risk?
Sure. So what I've done till date is acute animal studies. So I've assessed the valve performance post-deployment after 2 hours. The plan is to basically perform some chronic animal studies, make sure that the valve survives and heals appropriately for 30 and 90 days. So those would be the next steps from a preclinical standpoint.
Left.
How long from start to finish in terms of time and money is going to be required? You're raising $5 million. How much are you going to need to get to the end?
Yeah, so I've broken it down into 5 phases. So design phase is the 5 million, verification is roughly 6, clinical feasibility is another 9, and validation, depending on the number of patients that would be needed, is somewhere between 45 to 75 million. So yes, it's a long run. But having said that, the next 3 phases, design, verification, clinical feasibility, are the next big would take us to the next big milestone. That's around 20 million.